let's consider a hydraulic system. Hydraulic system, we've got a cylinder, we have another cylinder over here, okay? Both cylinders have movable pistons at the end of them. So this movable piston over here has, we'll call that radius R2, 6.5 centimeters. And this one over here, R1, let's say that R1 is going to be equal to 0.5 centimeters. And so we have a heavy object M right here, okay? And so it has a force of mg on it, okay? So mg is pulling down, but if I exert a force down over here, called F1, then that pushes down here. Well, there's got to be a push up, right? Equal and opposite forces. So this pressure here has to equal this pressure. So P1 has to equal P2. Again, we're at Pascal's principle here. And so so that's going to push up with a force. So I want this mg down to be balanced by the force F2. So in other words, I want to know what force F1 balances this force mg. Okay, so that means that I want to know how does F1 and F2 relate to each other. Okay, now pressure is force over area. So that means this is going to be F1 over A1, and that's going to equal F2 over A2. Okay, well, that's going to mean that F1 over pi R1 squared equals F2 over pi R2 squared. Okay, so F2 is going to be R2 squared over R1 squared times F1. Okay, if I plug in the numbers that I have there, 6.5 for R2 and 0.5 for R1, okay, then what I find is this is 169 F1. So that means if I push down here with 1 pound of force, I end up pushing upwards on the other side with 169 pounds of force. Okay, and so if I push down here with 2, or even if I push down, let's say, if I push down here with 5 pounds of force, that means the other side is pushing up with 845 pounds of force. Okay, so this is how a hydraulic jack works. You push down with a force here, and a much magnified force is over here. This is how the hydraulic system of the brakes of your car works. You press down the brake pedal, and the lever causes a cylinder to be compressed right here, and then in the brakes, a larger diameter cylinder pushes this way and pushes the brake parts together. And so that magnifies the force of your that you're applying to the brake pedal. Now, this is an interesting thing because, this is not like the Flintstones where you drop your feet and just drag them, because it's magnifying the force. Most cars, your parking brake or emergency brake is a purely mechanical system. So that means it just does it with levers and pulleys. And that's not going to magnify as much as the hydraulics. And so if you're driving along, you press the brake pedal, it stops your car in a certain distance. Whereas if you're driving along and you stop with the emergency brake, it takes much longer to stop because you're not magnifying the force as much. It's actually not a bad thing to do, is get on a road where there's no one else on the road and stop with your emergency brake just to see how long it takes to stop, because it does take much longer to stop than it does with the regular hydraulic system.